Welcome everybody, how are you? Today we will complete our questions about limited, such that limited when x approximated to positive 1 of ln x power 7 subtract 1 subtract ln of x power 5 subtract 1. If we put 1 here, the result will be 1 minus 1 equals 0, ln 0 equal infinity, and here the result will be ln infinity, ln about 0 equal infinity, infinity and infinity, and define. So we must using rule about properties about ln. We can write here limited about ln and write x power 7 subtract by 1 in numerator and x power 5 subtract by 1 in denominator when x approximated to positive 1. We can use the rule about this expression. We know 1 power 5 equal 1 and 1 power 5 equal 1. The result will be 7 over 5 multiplied by 1 to power 7 subtract by 5. We can use the rule about this limited. So the result will be 7 over 5 multiplied by 1. The result will be 7 over 5. Okay? Or you can find derivative about numerator and denominator. Another example. Or you can complete, or another method, we can solve it here. Find derivative about numerator and denominator. You can find derivative about x and here derivative about x. The result will be here 7x power 6 and here 5x power 4 when x approximated to 1 positive. So the result will be 7.5. It's another method. Okay, another example. We want to find limited about 1 over x subtract 1 over e power x subtract by 1. We know if you put 0 here, when the result will be infinity. 1 over 0 infinity subtract infinity, and defined. So we must using cross about two denominator here, or write least common multiplication about denominator and denominator. So we can write limited x approximated to positive of 0, and we can write here x multiplied by e power x subtract by 1, and here we can write e power x subtract by 1 subtract by x using this multiplication, and here multiplication, and here multiplication. So we can here find derivative about numerator and denominator, and if you put 0 here, the result will be here e power 0 equal 1, 1 minus 1 equals 0, negative 0, the result will be 0 here, and 0 multiply a number equals 0, it's undefined. So we must using derivative about numerator and denominator. We can find derivative about x here and derivative about x. So limited 0 positive equal, and we can find derivative about numerator and denominator. About e power x, derivative about it will be e power x. Negative 1 equals 0, and the negative x will be negative 1. And we have multiplication about two term here. First, you can write first here, and derivative about second will be e power x. First multiply derivative the second plus second multiply by derivative about first will be 1. Okay, and we must put 0 here about numerator and denominator. The result will be 1 minus 1 equals 0 over 0. It will be undefined. So we must will be derivative again about numerator and denominator. So the result will be limited when x approximated to positive of 0. The result will be e power x, and here we have x multiply e power x. We can write first multiply derivative about the second plus the second multiply derivative about the 1 plus derivative about e power x. It will be over x, negative 1 derivative about it equals 0, and we can put here 0, e power 0 equal 1, and 0 multiply in a number equals 0, e power 0 equal 1, e power 0 equal 1. The result will be 1 over 1 plus 1 equal 2. The result will be half. Okay, in this example we have to find the limited about x approximated to 1 to infinity, and ln x power 2 over x. We can find the result by here put x equal infinity, ln infinity over x. We have here the result will be infinity over infinity and defined. So we must find the derivative about numerator and denominator. So okay, the result will be infinity over infinity, and it will be undefined. Then we must find derivative about numerator and denominator. About limit of x approximated to infinity. Here we can drop 2 outside here. 2 multiply of x multiply by derivative about this function will be 1 over x. Derivative about x equal 1. And then we must write here infinity. 1 over infinity equal 0. And here ln of infinity equal infinity. So the result will be undefined. Okay. So we must find infinity over infinity undefined. So we must derivative again about numerator and denominator. Then we can write x here in the numerator. So we can write limit when x approximated to infinity to multiply of ln of x over x, and we can derivative about x here and derivative about x. We can write 2 outside here. It's coefficient about this function. Ln of x derivative about it will be 1 over x, and here derivative of x equal 1 when x approximated to infinity. So the result will be 2 multiply by 1 over infinity equal 0. 1 over infinity equal 2 multiply 1 over infinity. 1 over infinity equals 0. So 2 multiply by 0 equals 0. The result will be 0. It's okay. Another example. You want to find about limited when t approximated to 0 e power 0 subtract 5 power 0 minus 1 equals 0 over 0 and find. So we must using derivative about numerator and denominator about t. So limited when t approximated to 0 derivative about e power t, we can write this term multiply by ln about the space, then 8 subtract by, we can write 5 power t ln of 5 approximating about t will be 1, and we can put 0 here. E power 0 equal 1 subtract ln 8 this dot ln 8 subtract 5 power 0 equal 1 multiply by ln 5. So the result will be ln 8 subtract ln 5. We can write it ln 8 over 5. It's the result about this limited. Look at this example. We want to find limited when x approximated to 0 positive e power negative 1 over x over x. Look at here. If you want to find the result, you must put 0 here. The result will be e power negative 1 over 0 plus over 0. The result will be here will be e power 1 over 0 equal infinity. Okay, the result will be negative infinity over 0. It's meaning 1 over e power infinity over 0. We know e power infinity equals 0. Okay, e power negative infinity equal 1 over e equal 1 over e power infinity. It will be equal 0. 0 over 0 undefined. So we must derivative about numerator and denominator. But if you do this method, you will getting any number because the denominator will be x all the time. Look at here. I will solve it, but we will stop in the end and we will complete. I will solve it where it will use you to know the properties. Okay, we know we must write derivative about x here and derivative about x about the numerator and denominator. Look at, we can write limit when x approximated to 0 plus. We can find approximating about e power negative 1 over x multiply by derivative about negative 1 over x. It will be 1 over x power 2, and derivative about x will be 1. Okay, if you put 0 here, the result will be e power negative 1 over 0 multiply 1 over 0. It will be 0 over 0 undefined because we can write it here limited when x approximated to 0 plus a power negative 1 over x power 2. The result will be 0 over 0 undefined. So we must approximate it again. If you approximate it again, you will get 0 in the numerator and so on and so on. So you will angry about this. So we must what? We must do what? We must using replaced about this. We know 1 over x equal 1 over x. We can write it in numerator and numerator e power x. Look at here. I will solve it here by the true rule. If you do this rule, you will get 0 over 0 all the time. So you must find the result. So we must thinking another method about this example. Look at here, limit x approximated to 0 plus. We have e power negative 1 over x. We can write it here. We can write 1 over x because we have 1 over x. We can write it here 1 over x, and we can write this term in the numerator. We can write 1 over x. Look at here. If we put 0, 1 over 0, it will be infinity. 1 over 0 equal infinity, and e power 1 over 0 equal infinity. E power infinity equal infinity. So we must using derivative about x from numerator and denominator. So we can write limit x. Look at here, x approximated to 0 plus. We can find derivative about 1 over x. We know x power x, it's meaning x power negative 1. We can find derivative, drop the power here, negative here, and x power negative 1 minus 1 equal negative 2. And derivative about e power 1 over x. E power x, it's meaning x power negative 1. Approximating about x power negative 1, we can drop negative 1 outside here, outside, and subtract 1 from negative 1. The result will be negative 2. So we can cancel x power negative 2 by x power negative 2. So the result will be limited when x approximated to 0 positive. We can write here negative multiply negative equal positive, or 0 divided 0 equal negative divided negative equal positive. And here we can write 1 over e power x, and then we can write 0 positive here. E power 1 over 0 positive, 0 positive equal infinity. 1 over 0 positive equal infinity. So the result will be 1 over e power infinity. We know e power infinity equal infinity. 1 divided by infinity equals 0. So the result will be 0. So you must use this method to find the result. Okay. Another example, we want to find limited about what? Look at here. Limited x approximated to 0 positive or 0 plus x power root of x. We must put 0 power 0 equal any number and define 0 power 0 and define. So we must solve it. Who can solve it? Look at, we will talk this limited will be L. I will talk it will be L. L equal limited when x approximated to 0 plus x power root of x. And I will put here ln, and here we put ln about this function. It's okay, we put ln about left hand side and right hand side. And we can using properties about ln here. Then we can drop power outside. So properties about ln function. We can write here limited when x approximated 0 plus ln of x power root of x. Ln L equals this number. We can drop root of x outside here. So properties about ln. Okay. So the result will be limited when x approximated to 0 plus root of x multiplied by ln of x. Who can solve it? We can find the result. If you put 0 here, root 0 equals 0, ln 0 define. So the result will here 0 multiply it was positive. So ln about ln 0 positive, it will be negative infinity, because if we draw this function here, if we put 0 here, the result will be negative infinity. We come from the right hand side to left hand side, the result will be negative infinity. So the result will be 0 here. If you put 0, the result will be 0 multiplied by negative infinity. We can find the result about 0 multiplied negative infinity. It was undefined. So we must find derivative about this function. We can find the derivative about this function. Okay. To find the limited, we must find derivative. Derivative about ln x multiply root of x. Who can solve it? We know derivative about this function. We have ln x and of x. We can write this inside here. Yeah, you can convert this limited here, x approximated to 0 positive, and we can write ln of x over 1 over root of x. It's okay, we can convert, or can using first multiply derivative by the second plus second multiply derivative by the one, as you like. But if you do this properties, it's very easy to find derivative about numerator and denominator and using the rule about limited. Don't forget ln L. Okay, complete with me. Then ln L will be equal derivative about numerator and denominator when limited x proximity to x plus. We have 1 over x, it's derivative about ln of x, and derivative about 1 over root of x. We know root of x, it's meaning x power half in denominator. It will be right x power derivative about 1 over x power half, it's meaning x power negative half, and here derivative about 1 over x. We want to find derivative about x power negative half. We must drop the power outside here. The result will be negative half, and then we can subtract 1 from negative half, subtract 1 equal negative 3 over 2. We can write negative 3 over 2 here. It's okay. This number we can write it here from the denominator to numerator to simplest, or we can find the 1 over x, it will be x power negative 1. So we can simplest it, write it here limited when x approximated to 0 plus, and write negative 2 in denominator and x power negative 1 over x power negative 3 over 2. And then we can find the difference between negative 1 and negative 3 over 2. Look at here, I will complete it here. We know in this example we solve it here. X power negative 1 limited when x approximated to 0 plus, x power negative 1, and here sign was negative, and 2, and here x power negative 3 over 2. We can simplest it. Limited when x approximated to 0 plus, we can write negative here and 2 in denominator, and x negative 1 plus 3 over 2. It's meaning 1 and half. Subtract 1 equal half. The result will be half. So the result will be what? We can write here negative limited when x approximated to 0 plus. We have half in denominator. It was half. Okay, negative half, negative half, negative half. We can write negative half in numerator. Denominator we will write in the reverse here. The result will be negative 2x power negative 1 plus 1 and half equal be half. It's meaning 3 over 2 1 and half, subtract 1 equal half. It's the result about limited negative 2x power half. And then we can find the result about put 0 here, so the result will be what? The result will be negative 2 root of x when x approximated to 0 plus. If we put the result here, negative 2 multiply by root of 0 plus. Look at here, it will 0 plus 0, root of 0 equals 0, so negative 2. Then we have ln of L equal to negative 2 multiply by 0 equal 0. So ln of L equals 0. Who can solve it? Ln of L equals 0. Can you solve it with me? We can write e here and e here. E power ln L, the result will be what? The result will be L. Okay, you must use these properties. Again, we have ln L equals 0. So e power ln L equal e power 0 equal 1. So e power ln of L, we can cancel it with it. So the result will be 1. E power 0 equal 1. So L will be 1. L is meaning about what? L equal this. So this limited, the result will be 1. The result will be 1 about this limited because we put this limited will be L. It's okay? Understood it? This example is very important. You must know all steps. Again, we put here this limited will be L and the L, and get ln from left hand side and right hand side, and we can solve it and drop root x here and put x equal 0 plus here, 0 plus ln of 0 plus equal negative infinity, 0 multiply negative infinity and find. So we can find derivative out numerator and numerator, convert this fraction, ln of x multiply root of x. We can write 1 over root of x in numerator to find derivative, and derivative about numerator and denominator. The result will be 1 over x multiply derivative about x power negative 2, negative 1 over 2, it's meaning root of x. And then I'll equal limited x, assume that a 0 plus 1 over x over negative half. We can drop the power outside and subtract 1 from this power. The result will be negative half x power negative 3 over 2 when x approximated to 0 plus. And we can simplify it here. Negative 1 subtract negative 3 over 2. The result will be negative 1 plus 3 over 2. And we have negative half. We can write it here the inverse about negative 1 over 2 equal negative 2. So the result will be negative 2x power half equal negative 2 multiply root of square root of x and put 0 positive here. Root of 0 equals 0, so ln of L, it was ln of L equals 0, so we must write here e power ln of L equal e power 0. You know e power ln of L equal L, so L equal e power 0 equal 1.